Yeah, we are now going back to sessions, and with me right now we have Billy Korando. Billy, how are you?
Hey Simon, I'm good. How are you?
Not too bad, not too bad. Holding up all right so far. Yeah, good to have you on, Billy. Is this your first session on the conference today?
Yes, it is.
It is.
First and
Awesome.
only,
So
so
welcome,
gonna get
welcome to
spoiled with this one.
and in fact, you're doing some track hosting a little bit later for us as well, right?
That I am. So looking
So you
forward to that.
Excellent. So you're seeing it from a few sides today.
Yeah,
Welcome to the conference. And now, Billy, you're a developer advocate at IBM.
yep, that's correct. I'm a developer advocate, kind of focusing on cloud and Spring, and we're going to kind of actually see a little bit of both of that here in a few minutes. So,
Wow, that's awesome to have
yeah,
a Spring advocate at IBM.
yeah,
That's brilliant.
I know. You wouldn't
And
always expect that.
yeah, absolutely. I mean, I remember when years and years ago when I was at IBM, fully behind the Java EE as they are now, of course.
Mhm.
But yeah, wouldn't have thought there would be a Spring advocate. But it's wonderful to see supporting the wider ecosystem, and it's a great thing to do. Billy, you're also a big community person, right? You're one of the co-leads of the Kansas City Jug.
That's correct. Yep. And actually, I'm gonna be doing some more live stream hosting with that tomorrow. So definitely check that out. You can find us on at KCJug on Twitter, and Micah Silverman with Okta is actually going to be doing a presentation on Spring and Vue.js tomorrow, about a couple hours later from now tomorrow. So it'll be pretty good.
Awesome. And so today you're talking about collaborative contract driven development. Billy,
That's right.
what does that mean, Billy?
So pretty much, we're going to get into it, and we're going to kind of look a bit at what is contract-driven development, because even though it's been around for a little bit, it's probably still something that hasn't really penetrated that far into the development world. And then we're going to look at to see how we can actually do it in a more collaborative fashion, to where it's not just you have to have a bunch of very specific Java idiomatic tools to do it, that anyone can do it, whether you're a JavaScript developer, C# developer, Python, or whatever it might be. You can actually do contract-driven development and kind of help your organization be a little bit more agile, a little bit more following good, like continuous delivery practices.
Awesome. That sounds awesome. Well, I won't take up any more of your time. I'll hand it
Right.
over to you, and I'll leave you in the most capable hands of Brian as well, who's also here in the background on this session. So over to you, Billy.
All right. Thank you very much, Simon. So yes, our presentation, we're going to be looking at collaborative contract-driven development. You can find me at Billy Korando on Twitter. You can also feel free to email me at william.korando@ibm.com. At the bottom of the screen here, you can see this is a link to this presentation, so you can follow that. I will also have a link at the end of this presentation to the GitHub repository, which actually has a more full presentation from this, because I've had to kind of bring it back down to fit the format. And it also has the code examples that I'll be getting into. Also, if you leave this presentation with an intense desire to know more, I do a lot of blogging on my personal blog at billykorando.com, specifically about automated testing. So you can check it out there. I've specifically covered contract-driven development a couple of times, and I probably will have some more here in the future as well. So if you kind of want to get more in depth on it, definitely check that out. So as I kind of was mentioning with Simon at the start of this, is while contract-driven development isn't particularly new, it hasn't really seen widespread adoption within the software developer community. So before getting into the depths of this presentation, just to give you an overall idea of what contract-driven development is, let's just take a very high-level view. And pretty much what it is you have your service, you have your client, and of course they interact with one another. So if a client sends a request to some sort of endpoint, and maybe if it's like a post request, it's going to have some sort of request body within it, that's going to go to the service, and the service is going to respond back. It could be 200 in this case, or it could be 400, 500, well, 500 probably when they really put this within contract development. But you would have some sort of response based upon that kind of request. And what contract-driven development is actually writing this out in a programmatic fashion that can be tested against as to what's going on without actually having to interact with a real live service. So what does this mean? How does it actually help you with contract-driven development? I kind of think back to this scene from It's Always Sunny in Philadelphia when one of the characters, Charlie, is going to go burn trash, and a couple of other characters, Mac and Dennis, try to stop him, and he's like, I'm going to burn this to turn into stars, but they're like, you know what, that doesn't sound right, but I don't know enough to say it's wrong. So how can we relate this? How does contract-driven development actually help us? Based on my career, I thought about 3 common things I've ran into and how contract-driven development could actually help with that. So let's kind of go through these scenarios using my favorite thing, GIFs. So in this first one, we're going to be looking at like an existing poorly defined service, like this, like some sort of generic customer service. It doesn't matter too much. So we have it here, and so it's like they need customer information and this client, and it's like, oh, okay, here's this customer service. Did you read documentation? Yeah, it's a Word doc, and you're calling called get customers to get customer information. So HTTP get customers, but it's a post endpoint. So nothing's getting back, and eventually they're going to get back here a 4 or 5 error. They should be using post. Okay, so they try doing post to get customers, still getting nothing back. Well, there's an Aussie header, of course, so they send that, and now it fails a 500. And it fails because, well, their database was brought down for maintenance, and they get back like a HTTP 200, but it has an error code in it. But nobody knows what the error code means or what it really means when an error like that happens. So it's just like a poorly defined or undocumented API. So, you know, and maybe it's also within like a bad format, like a PDF or a Word doc or something like that. That's not really easy to kind of translate into programmatic use. You could also have inconsistent behaviors or patterns. So like you have an endpoint called get customer info, but instead of it being a get, it's actually a post, which, you know, if you want to follow REST or not, that's fine, but it can be kind of confusing for some client or some user of that service to see that. And then they're going to get the wrong idea, and it makes it really hard to just kind of naturally use that service. And then finally, you have problems when you're testing against a live service. Some backend service could go down, like a database or maybe some other service that that service depends upon, that causes it to, any request to it to fail, but it has nothing to do with the request the client are sending it. So it can be very difficult and confusing when you're developing against it to know, wait, is this failure happening because I'm using it wrong or because there's actually something wrong with the service? So that's kind of one set of problems. Another one is it's like, okay, we're going to use some new development. We kind of went through our whole like design process, and now we're actually ready to get going development. And oftentimes what happens though is the backend service developer, everyone has to wait. The clients have to wait until that service developer kind of has something ready so they can test and build again. So it's like, oh, is that API finalized yet? Well, no, they're updating the model. And you know, they want to do some work, but now that service developer got pulled into a prod issue. So while they're on working on that prod issue, all these features, order summary, address form, and so on, they're all kind of stuck while they're waiting for that service developer to kind of get back onto the project. So kind of what's going on here is you can't really develop in parallel. The clients really, I mean, they can maybe do some work ahead of time, but really they're dependent upon that service developer actually having at least some nominal, you know, minimal viable product service available for them to actually work and develop against. And what this means is now your timeline to getting that service or that feature out to production and used by users is impacted by delays in both the service and client developers. So if a service developer is pulled into a prod issue for a week or is on vacation for a week or sick for a week, you're delayed by a week. If a client developer is similarly going to be impacted by a week because of something coming up, you know, that's going to add 2 whole weeks to that timeline. Whereas if they were both working in parallel, you know, maybe you won't be impacted by that at all, or maybe only really impacted by a week. Also then, like, once the service developer finally has some minimal service available, a client developer maybe has to get back up to speed on how they want to actually consume that service because they kind of forgot what they're going to do because it's been a week and a month or longer since they actually had a lot of those design meetings. Finally, you just have like this actively used service there. And sometimes, you know, someone makes a change to a backend service, you know, someone like perhaps myself, when I was still actually doing real development work, you know, they see something like API get customers and like, oh, that's not properly RESTful. They're going to change it to customers. and they just push it out and they don't tell anyone about it. And so sometimes like this happens. A change gets pushed to production. Oh, when did it go to prod? It went last night. Well, at least now you know what all the prod errors are about. But now this poor client developer is going to have to stay late to get it fixed. And oh yeah, by the way, that service developer has also pushed up a customer model change, again, without telling the client developer. And they're always the last to learn about these changes once they get to production. And now they have their hairs on fire trying to put out this production issue. So again, you just have a breaking API change not caught until production because maybe just no one knew a new change was going to production or just didn't know that this change was going to have this sort of impact. Maybe the developer, when they were making that change, didn't themselves realize it was going to kind of have this impact. And then also another problem is like the service developers, they pretty much have the full control over what the API design looks like. And that can be maybe an unpleasant experience for client developers because maybe that model, maybe the endpoints aren't set up to work that well for what they need. So this is the overall case for contract-driven development and what it is. So let's start digging into a little bit more, looking at Spring Cloud Contracts. So why should you consider it? Well, it's a very active project. There's ongoing changes and features being added. So it's not something that was just had an initial release a couple of years ago and hasn't really been touched since. It's ongoing and in active development. It's also interoperable with other tools and standards like OpenAPI, Pact, Swagger. It also has really great documentation support with Spring REST docs, which is backed by ASCII Doctor. And it also has polyglot support, which kind of gets to that collaborative portion I was talking about early on when I was talking with Simon at the intro. Anyways, you can read more about it here at the project link. So what does this contract look like? Well, there's a couple of different ways to write contracts. Initially, when Spring Cloud Contract was initially released, it was all in Groovy. And here's a very simple contract showing an example of doing a post. So here we have like a method post to API persons with a body of name John Doe, and it's going to give back a status of 201, which means created, and then it's going to have a link to that new person's object. Here's what the exact same kind of request would look like if you were using YAML. So there's Groovy, there's YAML, I believe there's Kotlin, and I think there might be one other. I think it actually could also even be in now native Java as well as a contract writing service, but I haven't done that. I've only done work with the Groovy and the YAML. So this is what the contracts look like. So who's actually writing them? So there's actually two different ways of writing contracts. Well, they're both the same kind of contract, but there's two different methodologies. So one of them is the producer-driven contract, where the producer of the service or the developer of the service writes the contract and be like, hey, the API will look like this to the client. And the client's like, okay, that's good. They have something to develop against. That's awesome. Another way is consumer-driven contract, where a client says, hey, I need this from the API, and they write out a contract, and then the server or the producer developer will then write those out. So it's important to understand, though, that whether it's a consumer-driven contract or a producer-driven contract, the contracts will look the same. They'll both have this request and this response look and so on. It's just a methodology of a kind of a push versus pull for how APIs should be developed and built. If it's producer-driven contract, the producer of the service, the producer developer is going to be like saying, pushing out what the contract is going to look like. Whereas consumer driven, it's the consumer kind of pulling that API in ways they want it and need it to be. One advantage of consumer driven contract over producer is you're maybe going to avoid some of that YAGNI, that you're not going to need it because all the API features and endpoints are being built based upon a specific need for clients, not the producer trying to assume what the clients actually need. Either way, both methodologies work, and both are much improvement over not doing contract-driven development. But also, if you want to do actual consumer-driven contracts, a lot of times they're not going to be Java developers that are going to be writing them. So you need to have language-independent tools. So Java developers are going to have a JDK, they're going to have Maven, they're going to have a Java-friendly IDE. That's probably not going to be the case for JavaScript developers or other type of developers. But now Docker has become fairly universal. And of course, every developer is going to have a text editor. So about 2 years ago, Spring Cloud Contract developed some Docker images that can encapsulate all the Java and Spring Cloud contract logic within these Docker images, and they have it for both doing the producer and the consumer side of it. And so with that, you can then use it to validate the contract. So you write these contracts out and you make sure the service actually meets that contract. You can also use that using the Docker image, not necessarily depending again upon like having Java and Maven and stuff like that. And so if these contracts work, then what you get is a stubs artifact that combines all these contracts together into something that's shareable, which then you can put into your artifact repository, whether it's internal or external to your company, because maybe you have external clients which are using your services. All the same, you can kind of do that there to share it, to have the current state of what that service looks like, or the API. You can also, again, create documentation based upon these contracts. And again, because these contracts are being validated against the actual current version of the service, you're going to have a lot of confidence that this documentation is going to be up to date with what the actual service currently looks like. You're not going to have documentation that was made when the service was first released, but has since become badly out of date. And then finally, you can have these clients, they can actually then test against these stubs artifacts, or you can also, again, use Docker to do this, or you can even have them test just directly against the contracts, which can help with doing that parallel development. So that way, once those contracts are actually written, both the producer and the client can actually go ahead, our consumer can go ahead and start developing and just develop to meet those contracts. So quickly, just to kind of review all this, we can write the contracts to define the behavior of the API, and the contracts validate the API matches the behavior. You can bundle the contracts as a shareable artifact. You can generate documentation from the contracts, and the clients can test and develop against the artifact. And what's critical is those last 4 points, except for I guess the develop portion, would all be automated. So that way you're always checking against it. So that way, if someone tries to make a change to the API or change to the contract, you're not going to accidentally break people in production or something like that. All right, so that was a whole lot of words. What does this actually look like in the real world? So here I have a really simple produce service, and I have a few endpoints, a couple of GET endpoints, a post endpoint, and so then I base upon that some contracts. So here I have my code repository. And again, in this, I have both the client, the producer, and then the contracts I'm writing against. And again, you can access this, so you can kind of look at it all later. But we're going to look at this one. So we have this one contract. It's called find produce by specific name. And so what it's going to do is do a GET to this endpoint, and it's going to expect back a couple of Apple items to be returned. Now, if we go back into my code, we can see here we have a GET mapping for name, and it's at API v1 produce. So that's how that relates to this API v1 produce, in this case, taking the variable Apple in, and that's what it does here. So if I was to comment this out, whoops, don't want to delete, comment out, and then execute these tests, and while they're executing, I'll show you this. So in Maven, if I was just doing this as a Java developer, I would configure this on Maven. And here I'm saying, go look for the contracts out here at my GitHub, Korando produce contracts, and run and test against them. So we had 4 test runs, and that was because we have 4 contracts out here: add produce, add failed, find all, and find produce by name. So 4 contracts, 4 tests, and then 1 failed, and that failed because I commented out this GET mapping for producer. So now the contracts don't match what was written in them. If I uncomment this out, I can run the test again, and now it's to succeed because now the API actually matches what's in the contracts. So this is great. So this is a good way of making sure, a good CI/CD process, where if I make a change to this code here, and I commit it to a repository and have it go through our CI/CD process, it's going to test every time against those existing contracts and make sure I'm going to actually meet it. Now, let's think about it from the client side. The client is going to want to be able to develop and test as well without maybe necessarily having to wait for me to actually get a service out and running. So let's see. Let me make sure I'm in the right area. Yes, there we go. So here, as I mentioned, the Spring Cloud Contracts team, they created some Docker images to encapsulate all this logic. So let's see what it looks like to actually use one of those. So here I created a script for just running one of these Docker images. And so you have the Spring Cloud Contract Docker image. And here I'm saying you're going to use these Maven coordinates of com IBM developer producer service. And this is just saying like use the most recent version out there, and it's going to be running at port 9876. And then it's saying to look again to here to my GitHub repository to pull in these contracts to actually run this produce service. Now, if I quit out of there and I run this, I'm going to get a example or a fake service behind, or a mock service running behind this. Under Spring Cloud Contract, you can see here it is actually using WireMock. It's kind of reading in those contracts, consuming them, and then using JSON to kind of mock out those requests. So if I go here to localhost 9876, produce, and Apple, I will go ahead and kind of get that response back based upon that contract. And now, if I quickly start up a little service that myself and a colleague helped put together. Actually, let me just go up a couple. There we go. So yeah, npm run start run contract. It's just going to start up a very simple Angular application. If we give it a couple of moments, it'll get started here. But one of the things that could be really interesting about this is one thing that's notoriously a little bit difficult about doing automated testing on front-end applications is sometimes they depend upon some back-end live service, and sometimes that data can change on you that could cause a test to fail. But again, that test is failing not because something actually changed in the code, but because of some back-end data change that could have just happened. And so now you have a failing test, and you kind of lose faith in those tests because they're just giving you false negatives about failures when they're not actually broken. So anyways, here these 4 returns are coming from this mock service. Here, whoops, fat fingering, there we go. So here we're getting like these 4 returns in JSON, and that's what we're getting back here. So like this service is actually talking to this mock service here. If we put in Apple, we'll get 2 requests back here. This is a very simple example, but I think it's a pretty interesting use case for how contract testing can really help in other unexpected areas beyond just development and just beyond just the testing and validation of the API itself. So some final points. While all this presentation, I kind of focused on REST and HTTP examples, you can also use Spring Cloud Contract for doing messages and event-driven messages and stuff like that. It's also totally okay to change contracts. You know, we have, at least in the US, like contracts are written in stone and so on, but it's fine to change them. They're there just to make sure that if someone either changes an API, then the contract has to be updated to change it. It's just making sure unsolicited changes can't get to production without anyone knowing is pretty much what it comes down to. Also, contract tests, they're not acceptance tests or replacement for end-to-end tests. They're just going to be part of a full test suite. So not going to be testing things like resiliency, timeouts, performance, edge cases, and so on. That's not the goal of end-to-end tests. It's just so overall what the API looks like, what it's supposed to do, given a certain request and response. It's not trying to, again, test edge cases. You definitely can't test performance because it's a mocked service. All right, so we're at the Q&A point, so I hope you stick around for that. Here are some links to all that, and I will also get this slides out to everyone here pretty soon, and like the Slack channel and on Twitter, so people can kind of get to this code and check it out for themselves. So,
all right,
any
Bill.
question? Hey,
man.
Hey, Brian.
Yeah, I just took over from Simon. I mean, it's European time zone, and some people do need to sleep. I, however, will go on for the whole night.
Got the big cup of coffee going.
Yeah, I've got the big cup of coffee going on, and we are we're going straight on. But the first thing I want to ask you personally is, like, if I want to start with that contract testing, because I see the benefits of it. But as you know, if I'm running a somewhat older application, we do have services though, and so I get it that things like contract testing should be can be interesting for me. How should I start? I mean, I find that difficult.
So how would you like start with like a new service, or maybe have like an existing service and you just kind of want to write some contracts for it?
Yeah, probably it's some existing service, because most of the time it's not the case that you run something from a clean sheet, or you can start from the beginning. But well, a lot of us need to maintain older applications,
Absolutely.
right?
Absolutely. And so for that is you can just kind of go ahead for even an existing service out there, just kind of go back and knowing how your service looks, write out some of these contracts and make sure that they test them and make sure that your API actually matches to them. And once you feel like the contract you've written actually match the current behavior of the API or the expected behavior of the API, you can then actually start using them to test to make sure that the API is continuing to meet the expectations of those contracts. And then you can start using those contracts, kind of as I was showing here at the end, as a stand-in for testing against that API without actually having hit that live service, which again kind of comes with that problems of like a database or some backend service being down, which could cause some tests to fail. Of course, kind of retroactively going back can sometimes be a little bit more difficult, but it's definitely not impossible, especially since this can be somewhat black box type of testing where you don't necessarily have to have, re-engineer your code to meet all the ends and needs of the test.
What do you say is the biggest pitfall people take when doing contract testing?
So some of the biggest pitfalls is, I guess, maybe giving up halfway through, or like not trying to test out every, I guess a pitfall would be not actually having the test represent what the API behavior really is, and maybe only say like doing happy path testing, stuff like that. So like here, this is like an example of a successful request, but you aren't limited to only doing successful requests. You can also do what happens if like here, like the client doesn't send like a required field like name or something. And then I can send back a 400 saying, hey, there's a missing value required. So you want to make sure your contracts fully cover the full behavior of the API that accurately represents what the API is supposed to be doing. If you just kind of hand wave it or don't, really make an attempt to follow what the API is supposed to be doing, then yeah, those tests aren't going to be of much value to you, or they're going to be limited value at least.
Okay. Well, that is about it. I get it.
Awesome.
So we have 1 minute left, and I'm actually just waiting for the next speaker. I'm waiting for let me see who's next. Raphael will be next. So okay. Billy, I want to honestly thank you for
absolutely
for doing this. Let me see if in the meantime there are new questions, because I don't see them on Slido. So nope.
Okay. All right. I will.
There's one. We have still 1 minute. So, is there any way to know how many clients are consuming a particular endpoint or resource? Is that?
I don't know. I guess you could maybe design a system. Like there wouldn't be an intrinsic way of doing that within Spring Cloud Contract, but maybe you could kind of see like how many people are pulling down the stubs or something to test against it. That's about the only thing. And that would probably be some more advanced orchestration in your ops or pipeline.
All right. Well, cool. Let's cut it off. Thank you for joining us.
All right.
And
thank you.
See you all later.
Absolutely. See you.